Hello, I'm Philip Patrick, fourth year student from Faculty of Manufacturing Engineering from University Technical Malaysia Melaka. Would like to present a FYP title named Effects of Stirring Time on the Real Cast Microstructure and Mechanical Properties of Magnesium Alloy. For the introduction of my project, so we can call that semi-solid state processing is a methodology that transforms dendritic as cast microstructure into a globular non-dendritic microstructure with optimized mechanical properties. So it can be said that real casting can enhance the mechanical properties of an material. So however, the enhancement of mechanical properties and microstructure for magnesium alloy is not widely studied. So thus, uh, this is one of the reasons why I happen to choose to do a study regarding on the real casting for magnesium alloy feedstock. So real casting process normally involve mechanically stirring metal in semi-solid state. So as we said that the raw casting normally for the uh, feedstock it is in something like jelly, it's slurry. So for the and the chosen material to study for the stirring time effect is magnesium alloy AM50. Hence, the microstructure analysis and mechanical testing will be conducted to study the effect of speed and stirring time. So next, the problem statement. So as I mentioned earlier, there are still limited studies on the semi-solid state processing from magnesium alloy. The limited studies for magnesium alloy can be due that magnesium alloy are very reactive to temperature change. So this is why there are so few specific study on magnesium alloy that can be found on web or journals. Now I'm going to talk about the objective and scopes. So for the first objective is to determine the optimum parameters such as the stirring time and stirring speed to produce the magnesium alloy feedstock. And second objective is to study the microstructure of magnesium alloy feedstock. And the last objective will be to investigate the mechanical properties of magnesium alloy feedstocks. So for the scopes, it will covers on the effects of stirring time and speed of magnesium alloy AM50. And it will be focused on the microstructure analysis of the feedstock samples and determine the mechanical properties through mechanical testing. So now I'm going to talk about the literature studies. So for the fundamental recasting will be from the Flemings, which says that recasting process has increasingly gained attention from many researchers due to its cost-saving advantages over jigsaw casting. Next is from Uman, 2015. It says that the rising interest of automobile and aerospace industry in lightweight material guides to focus on material with a lower density, for example, aluminum and magnesium. So magnesium is known for its light density, so it's very a good choice of material to be used in automobile and aerospace industry. And next is the TT Trang 2018 auto magnesium alloy as the lightest structural alloy. It offers a significant potential for automotive application, and their applications remain limited due to their poor formability at room temperature. So for this one, if to relate to the previous one, so magnesium alloy, being known as the lightest structural alloy, it can be used in automotive application. However, it is limited due to its poor formability at room temperature. And next is from the K Park, J Park, and Hescon 2018. With the requirements of environment protection and lightweight of automobiles, magnesium alloy has gained increasing attention due to their important value and application prospect. So with this case, is known magnesium alloy holds a very special characteristic that can be used in application prospect of various application. So last study is from 2019 says that in the aerospace and auto industry, with high demand in weight reduction to achieve energy efficient and strength improvement for structural application at ambient and elevated temperature, the magnesium alloy containing heavy rare earth elements are meeting this requirement and receive considerable research. So magnesium alloy, where it contains a very special rare earth elements, can be used for the structural application at ambient and elevated temperatures, where it can achieve energy efficiency and strength improvement. So now I'm going to talk about the flowchart of the study from my FIP title. So from start, you can see next start we will prepare the feedstock, which is the magnesium alloy AM50. So then we will melt the magnesium alloy. So after we melt magnesium alloy, we need to determine the optimum parameters of speed, time, and temperature. So now we're going to proceed with the real casting. So if the real casting is in perfect condition, then we can proceed. Then if not, we need to prepare it one more time. So after we gotten the real casting samples, which is the ingots, then we can move to the sample preparation. So to prepare the sample, need to polish and etching so that it's easier to be analyzed through microscope. Then afterwards, we will be microstructure analysis and mechanical testing will be done simultaneously. So for the microstructure analysis, it will be covered in two parts, which is the using optical microscope and a scanning electron microscope. So for the mechanical testing, it will be the hardness test and tensile test following the ASTM spec. So then we proceed with the result and discussion. Then we will end the study. So for the methodology for objective 1, so the recasting process will study the influence of stirring time and speed of magnesium alloy feedstock. So the parameters of the stirring speed and time will be set. Isothermal stirring will be executed for 4 different sets, which are the 1 minute, 2 minutes, 4 minutes, and lastly will be in 8 minutes. So various ingots will be produced with different stirring time and speed condition. So in total, there will be 4 specimens produced after recasting due to 4 different conditions. So the process flow to achieve objective 1 is from the feedstock preparation until towards the melting of the magnesium alloy. Then after that will be in recasting. After we gotten the recasting sample using the optimum parameters of speed, time, temperature, then we can achieve the objective 1. The objective 1 we will use for the design of experiment of Taguchi method. So from here, objective 1 will be achieved, whereas to determine the optimum parameters such as stirring time and speed to produce magnesium alloy feedstock. So for the methodology objective 2, the specimens produced from the previous methodology will be used for microstructure analysis. So the cylindrical sample with different diameters, which are the 6 and 12 millimeters, will be collected to evaluate the cooling rate effects. The microstructure will be analyzed through optical and scanning electron microscope. So for the microstructure, optical microscope will be used to check the structure of the magnesium alloy, and scanning electron microscope will be used to check the phases of the magnesium alloy. So here is the process flow to achieve objective 2. So after we gotten the sample preparation and will be polished and etching, so we move towards the microstructure analysis using optical microscope and scanning electron microscope. Objective 2 will be achieved, whereby is to study the microstructure of magnesium alloy feedstock. So for the last objective, the methodology objective 3, so mechanical testing will be done for cylindrical specimens. So there will be 2 types of testing will be conducted, which is hardness test, the viscous hardness testing, and another one is tensile test. So that we need to find the optimal tensile strength, the elongation, and the yield strength. So both tests are done according to ASTM E8 and ASTM E92. So the process flow to achieve the objective 3. So after we gotten the sample preparation from the ingots, so now we move to the mechanical testing, which is to investigate the mechanical properties of magnesium alloy and feedstock. So for the hardness test, it will be done at least by taking 5 to 10 reading to get the accurate reading. And for tensile test, we use another machine to study the tensile strength. So to sum up the methodology, the summary of methodology. So for the first objective, is to determine the optimum parameters such as stirring time and speed to produce magnesium alloy feedstock. So the output is to able to find the effects of stirring time and speed produced from various ingots of magnesium alloy with different parameters. And the second objective is to study the microstructure of magnesium alloy feedstock, where the output will be to be able to analyze the microstructure of different parameters of specimens of magnesium alloy feedstock through optical and SAM. And the last objective will be to investigate the mechanical properties of magnesium alloy feedstock and able to determine the influence of solids, semi-solid state processing on the mechanical properties of magnesium alloy feedstock through mechanical testing. So what are the expected results? So the expected results will be the enhancement of magnesium alloy mechanical properties, and maybe it will be less porosity in magnesium alloy and a good microstructure distribution in magnesium alloy. So these three are the expected results from my study. So that's all from my presentation for this slide. So thank you so much.